Okay, for this video, I'm going to be going over these three problems from the textbook, page 340, number 38, number 60, number 64. These are some just tricky ways in which you might see the difference of squares, so I wanted to show it to you guys before you guys saw it on maybe the quiz. But first, let's give a joke. How do you make 7 an even number? Oh, well, you just take the S out. Ha 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 ha. All right, cool. Number 38. Okay, so when you look at this, you kind of sit here saying, well, I got squares, I got fourth roots, and I'm not really sure what's happening. It just looks messy. But what you can do with these exponents is you can actually pull stuff out. So you can say AB squared. See, we're going to pull out that 2 root. And we can do the same on the other side, in which we'll have A squared B. And we're pulling a 2 out. If you guys remember our exponent laws, this is totally okay to do. I can't remember which chapter that was, maybe chapter 6, if you wanted to go back and take a look at exponent rules. From here, we're in a position in which we can do the difference of squares formula. So we're going to take this whole component down and say AB squared plus, then this whole component will move down, A squared B times the same stuff, but with a subtraction instead. Okay, and this is our final answer. All right, good. The next one is number 60. And that says we have 343 minus 7 times x plus 3 squared. Again, we're sitting here and, well, we can't really factor yet, so we should do any math that we can do. To me, it looks like we have the 7 pulled out, so why not just divide by 7 and get rid of it? It looks kind of funky sitting there anyways. So we'll divide the whole thing by 7, and that's actually going to do a lot of good for us. 343 is divisible by 7 to 49, and now we have x plus 3 squared. We're almost there, but we're actually in a position where we can do difference of squares because 7 is just, or 49 is 7 squared minus x plus 3 squared. Now, once again, we can do our formula. So this equals, okay, and we're going to take this component and just put it down. So 7 plus, and this whole component, bring it down, x plus 3 times 7 minus the same component, x plus 3. However, we're not done here. We can distribute this 1, and there's a negative 1 right here. We can distribute this and do some arithmetic massage. I'm going to go kind of quick on this, just fast steps. This is actually 10 plus x, and this right here is actually 4 minus x after you've done our distributive property. This comes to here, this comes. Okay, I'm going to show you guys one more, number 64. When you get to this, you kind of look at it and you're like, well, what do I got? I have a trinomial here, and then I have this y squared just kind of hanging off on its own. So this is one of those situations where if you don't know what to do, take what you do know and factor it. So when you factor this, it becomes x minus 5 squared minus y squared, which actually leads us to a position where we can do difference of squares. So this will equal, we'll take this component, x minus 5 plus y, this component, and this is multiplied against x minus 5 minus y. And this is actually our full answer right here. There's nothing else we can do. Okay? So these 3 examples were examples of harder difference of squares that you might see on the quiz or test. If there's any questions or comments, please let me know, and we'll see you all tomorrow.